Learning analytics is a well-established field that aims to make use of vast amounts of digital data to understand and enhance learning and teaching practices. The rise of generative artificial intelligence, or GenAI, has sparked discussions about the synergy between GenAI and learning analytics. We are privileged to welcome Professor Dragan Gašević to share his insights on this topic. Professor Gašević is Distinguished Professor of Learning Analytics, Director of Research in the Department of Human-Centered Computing at the Faculty of Information Technology, and the Director of the Center for Learning Analytics at Monash University. He investigates how GenAI creates a new educational context.
I'm going to be speaking about learning analytics in the age of AI. I'm going to give a very interesting, spin of it. I'm not going to be necessarily talking about the cycles of learning analytics and everything else. I'm going to be talking about very specific thing that I think learning analytics should play in the age of generative AI. Everybody is talking about this huge elephant in the room, generative AI. So I don't need to actually justify why we are talking about that. But this basically scared many people about a year and a half ago. Many organizations in the country where I am, they got a fairly visceral reaction to this point, and they basically even thought they can ban generative AI in schools or higher education. Didn't happen. Thankfully, they realized and they then allowed. They use sometimes very lousy excuses in schools. Well, terms and conditions on the use of ChatGPT means that you cannot use it if you are under 18. Which basically it's okay, but it's not necessarily educationally justified. But the reality is that AI is not going to go away. Generative AI it may have different iterations. Maiga presented an interesting take yesterday. He has far more faith in automatic detection of generative AI content. Our research shows that in best cases, when we have very realistic data sets, accuracy about 40%. And that's the state-of-the-art algorithms that we are coming up with the top AI conference as well. When we have some very synthetic, idealized scenarios, then we get pretty good accuracy. But there's this data sets called co-author generated by Stanford, and the results are not that encouraging. On the other hand, there are some really encouraging things with respect to the use of generative AI. So first of all, exposure to generative AI is projected to be affecting almost 80% of different types of jobs, according to OpenAI and the University of Pennsylvania. They recently even published a science paper on that topic. And more than 80% of the professions will have at least 20% of the exposure, according to that estimate. We'll see what happens. Exposure doesn't mean automation of these jobs. It means also the use of some of these generative AI. There was a study by Stanford and MIT showing 35% increase in problem solving, mostly in different types of customer services organizations. Except that it was primarily for novice workers, while for experienced workers, there was no observed improvement in the process. Software engineers also demonstrated 46% in productivity while maintaining the quality. And then finally, there's the fundamental architectural flaw of generative AI. It always hallucinates. We can have lots of different fixes, but it's a fundamental flaw that cannot be easily fixed. So as you can see, we live in the landscape in which people need to have novel types of skills. And we need to be working on adaptive learners who are capable of adapting at a very fast pace that generative AI and next iterations of AI will be bringing. Job for life, maybe, but you need to adapt. You need to be able to upskill, reskill, not only for a job, but to participate in the society, to get access to the health, financial, and other types of services. We tried to warn an Australian society through an op-ed published in the main newspapers in 2020. Nobody cared. Until they saw ChatGPT. People had to experience it. So the ultimate goal is to think about developing human skills while benefiting from the power of AI, where we basically need to think about two key dimensions. One dimension is where we are using AI to optimize our task or work performance. And that's basically where we are using AI support tools, such as ChatGPT and you name your favorite tool. The important thing as part of the process is that these type of AI supports also need to be good fit for the task. If they are not good fit for the task, you may not actually be able to make any good use of it. And also you need to have some good knowledge of the tool. And then there is this other dimension, which is the good old thing that we do in education. We scaffold our learners to learn and acquire skills. So we basically have one dimension that is aiming what I call AI-empowered skills. And these type of skills may be demonstrating enhanced performance. The question is, do they enhance human skills at all? What is the ultimate goal that I'm seeing is that we want to have, at the same time, empowered AI skills, at the same time, enhanced human skills as well, and to get the additive effect of the two. So it's a very simple derivative of this conversation is that we don't really imply high human skills with enhanced performance with AI. That is to say that high human skills are not equal to AI-empowered skills. And I'm going to give lots of examples. But in today's talk, I want to make the case for learning analytics in this landscape. The argument I'm going to try to put for you today and give you lots of claims and supporting evidence as well for those is that learning analytics is our best shot to explain and assess skills for the age of AI. Because existing assessment approaches cannot be easily used in this landscape. So this is the space we are talking about. Generative artificial intelligence is really something that is influencing learning. And we have the assessment of the people's skills. What is present state is that we so much fixate on assessing people's products. Students' essays, students' memory recall, software code, etc., as if nothing else is happening except that final product that we need to assess. So generative AI is providing us two things. It gives us lots of methods and techniques and tools, if you wish, that we need to account, and they can also help us with the assessment. But at the same time, given the model that I also showed, is changing the context in which people have certain skills. Because we need to assess different skills. So therefore, our assessments need to use these AI methods, while at the same time, our assessments must be informed with this changed context. That's really important thing. But what I'm basically arguing is that assessment itself is done through analytics for assessment. And we had a special issue a couple of years ago in Computers and Human Behavior, in which we identified that one of the key intersections of analytics and assessment is the use of analytics for assessment. And I'll be demonstrating that today. But specifically, what I'm arguing with this is that the use of analytics for assessment is actually leading into formative assessment. Assessment that is aiming at human development. Assessment that is supporting human learning, that is not offering just a snapshot insight into the human skills, but is actually trying to lift up our skills as a form of a feedback as well. And there's a strong argument to make for that. This is the cycle of learning analytics. With the three key steps that I'm identifying, you can decouple these key three steps into many others according to your wish. We collect lots of digital data about people's interactions with different technologies. We analyze these data with different types of AI, statistical, machine learning, network science methods to provide insights that can inform our transformation of practice. That transformation can be done by different ways. We change our practices, developing certain tools, developing different feedback mechanisms, and then we again collect the data to see how that transformation affected what we've done. So this is the reason why analytics has really effective thing. So then The big question I want to try to answer in today's talk is this sufficient to assess combined high human and AI-empowered skills? And I'd love to give immediately my conclusions. Number one is that there's much promise of process assessment in authentic situations over time, meaning longitudinally. That's number one conclusion for you. Number two conclusion is that we have really very limited understanding of combined human skills and AI supports. We don't really understand that in detail. And the number three is, if we are serious about the assessment in the age of AI, we need to move away from process, of course, move away from just products, and incorporate also assessment of metacognition and processes that sit at the core of assessment. That's my talk for you for today. All right, so I structured the talk to start now talking about these new methods. We can basically use some of these new methods to actually introduce some of the new properties that can advance our assessment practices. I'm going to be primarily focusing on the things that can affect our existing practices that have been focused primarily on the human skills in the way how we've conceptualized them for centuries. In that very special issue that I mentioned before, we argued that assessment itself can benefit from the use of AI and analytics in 4 key dimensions. One, assessment is very time-consuming. Takes a lot of time and effort. We saw it the case yesterday in the keynote, more than 500,000 people in a university. How to assess and support so many learners. So AI analytics offer approaches that make assessment far more feasible to be done. Assessment often is very discrete, just tiny snapshots very rarely in the process of time. We can make that much more continuous with the AI. Third is something that many people know. Assessment is just supposed to be uniform. It can be adaptive. It's been commonly used also in adaptive computerized systems. Many of you have that, so I'm not going to be talking about it today. And the third thing is assessment can become far more authentic. We can put people in far more authentic situations to do certain things. So I'm going to be talking about these 3 key dimensions and what can be done. So in terms of the feasible assessment, for example, what they are doing at Duolingo. Duolingo has Duolingo English test that is competing with IELTS, TOEFL, and everybody else. It's digital first test. And they basically also are using lots of things that is generative AI. Generating items, having human in the loop as part of the human-centered artificial intelligence approach. They also have lots of interactive opportunities for the learners so that these little characters also have speech that is also done by generative AI that is supporting video alignment. We also have seen that with the generative AI, we can have very high reliability of automated essay scoring and short answer scoring. That's basically on par with human in terms of inter-rater reliability, what we are getting. To me, what is even more exciting, and we've spent much more, is that we can actually teach students about good writing practices, that they can use different rhetorical structures. So for example, we use and work with the School of Law, helping students to write case notes and how these case notes should look like, argumentative essays, reflective essays, etc. But what I already emphasized is while we can score students with these type of things, we can also build that as direct feedback for the students that is scaffolding the improvement of some of these skills. So this is the example from the environment we call Flora, that is supporting students' reading and video comprehension in writing-intensive tasks. Inside of Flora, we also support the assessment of students' writing skills. One of these assessments is how good they are at integrating different sources of information to make strong arguments. And this tool is directly providing them with feedback on every sentence, how integrative it is, or how much they are just recalling the information, trying to nudge them in the direction of improvement of their writing skills. We recently completed one study in which we demonstrated that the use of this tool rapidly increased students' own self-assessment. As we know, we are highly unreliable at self-assessing. In our study, when students did not have this tool, correlation between their actual scores on the essays and their self-assessments was minus 0.5. When they used these type of tools, self-assessment flipped the sign, became positive 0.5. So that basically tells us a really strong promise that these type of technologies can actually move from the relatively low metacognitive skills into the higher improvement of the metacognitive skills over time. Number 2, continuous assessment. I love to say that process measurement is the dark side of assessment in the same way as we have the dark side of the moon. Completely unexplored. We don't understand it. We don't penetrate it sufficiently. Colleague of mine, George Siemens, when we started learning analytics, calling it penetrating the fog. And that's what we want to do. What is happening behind that fog that we don't see because we don't know, we cannot see cognitive, metacognitive, and other processes. Inside the Flora environment, we basically developed lots of different tools that are helping learners with different tasks. They can highlight information, they can search information, they can take different notes, they can plan their learning, etc. We call these pedagogically valuable tools. But at the same time, these tools are, we call them for research purposes, instrumentation tools, because they give us insight into students' cognitive and metacognitive processes. So while students are using these tools, they leave the digital traces, clicks, mouse movements, keystrokes. In the lab setting, we can also use eye tracking data, etc. We spend a lot of time developing the algorithms that can map these, we call raw digital trace data, into the footprints of cognitive and metacognitive, affective and motivational processes. And you can say, okay, Dragan, that's fine. But why we should be bothered with what you've done? This is a recent study as well, in which we demonstrated that the prediction, or better to say, assignment of scores to the student's essay was explained the most by these process measures rather than by the measures of just the quality of the final product. So how much time students spend on planning their learning or elaborating and organizing information, how much time they spend orienting themselves and so on, explained far more variance in the outcome than what we've got by just the coverage of particular topics or the essay cohesion, the traditional types of measures that are done to use. So this tells us that we can do these type of things with the process measures, and they can also help us to nudge the learners in the direction of the improvement of their learning. This is the other thing that is a bit more technical. These little dots here represent something which is the centroids of epistemic network analysis. The blue dots represent the networks of the students who were top performing in the class. The red dots represent the networks of the students who were bottom performing in the class. You can see clear clustering of the differences between these two groups. We can statistically tell the differences between the processes of the students who are doing well versus those who are not doing well. For each student, we actually have something like this. This is the network or the way how they are going from one process of self-regulated learning to another one. Also, the colors in this diagram demonstrate that blue students have many more connections between different types of processes, while the red is for the low-performing students. low-performing students only prioritize the only one goal, summative assessment. They don't really engage into planning of their learning. They don't really carefully set the goals. They don't carefully also engage into different types of tasks. They just think we need to focus all our time on the assessment, and that's it, bypassing many of these important things. But then why this is then important to have this kind of process assessment? And this is also what we have in Flora. We can then use these insights from the data to feed them into ChatGPT or GPT technology to generate advice for the students. This is AI in action, that we have our analytics that assess students' processes. They made certain conclusions, and GPT is then generating the advice for them. And GPT was fed with the content we asked students to study and the knowledge of the students' processes. And it is then actually looking into this whole thing. What we found so far, and we published relatively recently also another study, is that the use of this type of analytics and this type of scaffolding of the students had a moderate effect on the improvement in the choices the students were making for their learning strategy. So again, this is very promising that we can go from the low human skills to the high human skills, as we demonstrated in some of our more recent longitudinal studies. The third and the final property and the third icon that I'm deriving for you today is also the authentic assessment. That's where we want to measure where and when learning happens. In our work, we basically do that in both physical spaces and digital spaces. Physical spaces is we do this in nursing simulation. We ask our students to wear mics. They also have the location sensors. We develop the whole then AI technology that is doing the analysis of the indicators in their speech about their teamwork as they are doing. Locations are giving insights also into the teamwork and also how they are paying attention to the tasks. And then digital spaces. In the interest of time, I'll be just focusing on the digital space. This is our recent work in which we are actually focusing on development of clinical reasoning skills. With respect to the clinical reasoning skills, we developed a virtual patient that students of medicine need to interview and diagnose and establish the diagnosis. And they need to submit that as part of the tool itself. So then they are chatting, and this chatbot is developed by use of GPT. Actually, GPT 3.5 worked just perfectly fine and saved us about 10 times in our budget in comparison with our initial experiments with GPT-4. Students then submit, once they completed the diagnosis, their diagnosis to GPT again, and they get full assessment. And the GPT is generating feedback for them and give them the score on both their diagnosis and the way how they interacted with the patient. It's a very authentic situation how it's done. So I'm wrapping my first part of the talk where sole purpose was to introduce these four icons, right? That we can establish assessment that has all these same properties at the same time. It can be a continuous assessment, it is feasible, it is authentic, and it can be adaptive to different types of learners. But what is missing, and what we are going to discuss in the remainder of my talk, is modern assessment is more than just trying to measure students' AI literacy. How we can apply these four characteristics of assessment that is enabled by analytics to measure also modern types of skills. That is to say, to see this cloud that we don't understand sufficiently. And that's basically the intro into the second half of my talk. New context. What is this new context? Well, we really need to understand what we are assessing. What is that thing that we are trying to do? And the biggest thing is also how we conceptualize this ultimate goal that I said, the combination of high human and AI-empowered skills. So I'll try to basically make a very simple conclusion here, and I'll give a couple of studies to evidence this. We really don't understand it. Very limited evidence of combined high human and AI-empowered skills. I'll start with one example, the skills to provide feedback. In the literature and education, there's a whole big movement that is emphasizing feedback literacy. So with good colleagues at the University of Queensland, we had a study in which we tried to see how students are providing feedback to each other. But the feedback was as part of the crowdsourcing task, where learners themselves are creating the questions that they can then use for them to practice. But we realize if you are crowdsourcing some of these questions, quality can be lousy. So then we introduce peer assessment and peer feedback as part of the process to improve the quality of these questions. So then we produced a tool for them, which is the AI support. It was not a scaffold. That tool itself provided students with the suggestion how to advise or even improve some of their feedback. So it was not aiming to improve student skills. It was primarily aiming to just basically give them a fix and empower their skills to do this type of feedback. Then we had a longitudinal study with 1,600 students over the course of 8 weeks. In the first 4 weeks, all students had this AI support. And then they were randomized into 4 conditions. No support at all, continued to have this AI support. They received a scaffold, which we call self-monitoring checklist, which was really a rubric, and they could actually do it by themselves. And then we also had one condition which combined this rubric and the self-monitoring. Benefits completely evaporated once we removed the support. Did not exist anymore. As if they did not do this ever before. Meaning, AI-empowered skills, you wore your exoskeleton, you were able to lift every heavy weight, but then nobody was actually trying to challenge you to develop a little bit of your muscle mass as a part of the process. So their skills basically also stayed at the rock bottom where they were. What we found is that when students were moved into this other condition, where they used this self-monitoring checklist, they had improvement in their skills, but they were not on par. They were still slightly lower than when they had the AI empowerment. That was basically the key thing. So what happened here is that students transitioned from AI-empowered skills towards high human skills. That's positive, but not particularly novel. Then why bother to take this detour through the AI empowerment and then develop skills directly, right? And then what we found is that combining the scaffolds for people and AI support did not produce any additive effects. We had students in either AI-empowered skills or high human skills. That's it. We did not know how to get the students into high human skills plus AI-empowered skills. We have no idea how to get there. Number 2, information problem solving. Study also done with colleagues with our Flora environment. In Flora, you can also choose ChatGPT, along with many different types of agents. So in one task, we asked students to use ChatGPT. Specifically, we run a study in which we asked first students to work on an essay for 2 hours, read the information, work on an essay for 2 hours. Then we basically gave them a little break, and then we asked them then to revise their essays of interest for today's study in 2 conditions. One condition had access to ChatGPT, and the other condition had access to the chat interface to this happy German fellow, who is a professor of academic writing in a top Beijing-based university. So that's basically what we did. We would say that, unsurprisingly, writing performance rapidly improved by using ChatGPT. It did improve also in the human condition, but this one was significantly better than the human condition. However, there was limited evidence of any metacognitive engagement of the students who were using ChatGPT. They were just basically getting the sentences from ChatGPT, pasting them and moving on. No evaluation at all. I call that metacognitive laziness. And I'm going to be basically also trying to briefly explain some of that. So meaning, this is the high AI empowerment. The students who had actual access to the human tutor, to the chat interface, in every single step, they demonstrated strong metacognitive engagement. They always monitored, they always carefully checked everything what was going on. Meaning, they were actually improving human skills. Just their performance was not as enhanced as it was with AI. Probably in the same way like we have the athletes who really, by practicing, they enhance their skills, but then when they dope, they actually outperform in comparison to their natural condition. So then the key question is, what are the long-term implications of metacognitive laziness? We know that writing is such a fundamental skill. Our judgment of the information is such a fundamental skill. If we don't develop it from the early age, and even at this adult age, I just turned today 24. So then what happens? What happens? We don't understand the ramifications of that. My concern is that they will be rock bottoming at the low skills. Part of the reason, one of the hypotheses that I've had for a long time is that the problem with these generative AIs, they have something which is called very high processing fluency. Processing fluency means, oh, it's so easy to see what is there. But processing fluency also has an underlying threat, which is called illusion of truth. When something looks very articulate, we have a tendency with our cognitive architectures not to include the second part of our architecture, the cognitive architecture system, that is actually critical of what they are looking into. And we basically take it as truthful. So recent study, not our study, another group published this study, is they found basically that people preferred far more the answers from ChatGPT over the human answers from a question answering forum, even though ChatGPT had in more than 50% of the cases inaccuracies. And in almost 80% of the cases was very verbose. We still love to be lied. That's something, as long as that lie is very nicely packaged. That's basically the illusion of truth. And that's basically what is the concern. And even this study demonstrated people maintain their low skills. The problem is that ChatGPT is not a question answering tool. It's a tool that generates tests, but does not have the up-to-date and accurate information. And obviously, people do not have the skills how to use this tool. So what are the key corollaries that I have before I actually give the whole vision? What do we need to do for assessment and the use of analytics to support us? Number one is that metacognition is a key dimension of high human and AI-empowered skills, except that inside of AI-empowered skills, metacognition gets disabled, or we become metacognitively lazy. And number two is that for us to actually have real evidence and assessment of the human skills in this context is that we need to have a longitudinal approach. Otherwise, how can we actually see what are the implications of the use and introduction of some of these tools? So what is the direction for us to take? I'm going to provide first conceptual, and then I'll give a very concrete example, and then I'll wrap up my talk for today. So, well-known thing in education or assessment is called evidence-centered design. It has three key dimensions. Student model aims to conceptualize what kind of skills we want to have and detail what are the properties of these skills. Number two, to define the tasks that we can actually use for learners to apply these skills. And then while they are applying these skills and conducting these tasks, they need to demonstrate and produce data about the evidence that they have particular skills or not. That's called evidence-centered design in these three components. So I'm going to return back to the high human and AI-empowered clinical reasoning, the example that I previously mentioned as well. So we want, number one, to have the tasks to be authentic. We all obviously demonstrated that. Number two, in terms of the process, the tasks need to introduce and include three key dimensions. Number one is they need to introduce scaffolds and then the fading of these scaffolds so that we can longitudinally track what's happening. The tasks also need to introduce AI supports, the use of some of these AI tools. And number three is they need to introduce information and the opportunities for learners to demonstrate and engage into metacognition through metacognitive judgments, metacognitive control, and so on. And critical component is they need to be over an extended period of time. They cannot be just one time off. It has to be longitudinal, weekly, daily, you name it, depending on your design and everything, what you want to do. So you see, we got these four icons that are applicable here. So let's go back to this example of high human and AI empowered clinical reasoning skills. I already introduced this example. Students are chatting with the virtual patient, and it is giving us this authenticity of the task that students are having. They're inside of this Flora environment that is tracking all their movements, collecting the data about the processes. And we did it, for example, in our case, students had 5 tasks in 5 consecutive weeks in which they were doing these type of things. And we changed slightly some of the patients. Number 2 is we also have another agent, another chatbot that students can turn to, whose role is to be an experienced physician. So we are actually modeling this situation, that students is working on something, and then they can also turn to the chatbot to a more experienced doctor that is another chatbot that is based on generative AI. And we can also understand how that scaffolding is happening. The purpose of this artificial physician is to actually guide the learner and give them advice, but then it's on the learner to go back and then to talk to the patient as part of the process. And the third thing is that learners also can have access to ChatGPT. So that's the AI support. You see, I basically demonstrated we have an authentic task. I demonstrated we are introducing the AI support. We introduced the scaffold. The tool itself is also having this whole metacognitive judgment. And now, final thing is the data. We basically collected data, clicks, mouse movements, eye tracking, everything. All these chats as well, the data about the products. We have the data about students' diagnosis that they can make. And we also have the data about transcripts of the interactions with ChatGPT, with the patient, and with the physician. And we can also all that automatically analyze with generative AI, not only enable it. Final thing is, this is not directly from this study of some of our previous research, we can again produce a model that is akin to the models that are commonly used in the assessment as well. And that is basically, in this case, epistemic network analysis of the problem-solving processes that students are going through. So we want our students to be in this corner of resolution. And then we can basically, for different conditions across the weeks, generate their trajectories. And they can actually tell us that this red trajectory is the one that is idealized, and that's where we want our learners to be. And that's our assessment that is actually based on the processes of the learners that is also factoring in the products that they generated along the way. So, one final thing before I go into my conclusions is that these assessments are feasible and scalable for one specific reason. You can see that in my analytics that I'm suggesting, generative AI is used all the way through. Generative AI is used in terms of the techniques that it can use to analyze the data, as well as to create all these chatbots. One of the main things that I'm seeing generative AI is really what we needed to invest years and years and years to develop some of these chatbots. Now they can be developed as a matter of weeks or days or hours. If you are really good at prompt engineering and you have a shell such as our Flora platform that you basically just put your prompts and there you go ahead with that. That's the really big benefit. Otherwise, generative AI, in my view, is okay, but it's relatively dumb as well. As one of the godfathers that is dubbed by the godfathers, Jan LeCun says, before we get to the human level generative, general AI intelligence, we need to get even this type of intelligence at the level of a dog or a cat. So that's basically when we are kind of looking at from the human perspective intelligence. So, wrapping up, few final remarks. I started from this proposition that our assessment with the use of analytics should lead us to the formative assessments. And I started from the proposition of the conventional wisdom that we've been using so far, that is having product data as the only thing we are focusing on. What I am actually suggesting is that our human learning should be also represented not only by products, but also about the data about students' metacognition, as well as the process data. If you want to have comprehensive assessments of the high human and AI-empowered skills. But what we need as researchers and also practitioners is urgent need to understand this combined high human and AI-empowered skills, because we don't understand them at all. And then I want to say that this is really great moment. I know that not understanding something is in our human nature. We should be afraid, we should be banning, etc. But this is the amazing opportunity. I mean, how many generations of educators before us had something to do so fundamentally different to change our assessment practices? Assessment is at the core of the politics of education. Assessment is the core of the power of the education as well. And it's also at the core of the pedagogies that we are doing. Our assessments cannot be decoupled from our pedagogies. So therefore, this is a really great opportunity and we need to embrace it. And on that very cheery note, thanks so much for your attention.